Inside every single thing that moves, your car, a giant cargo ship, a jetliner, there's this constant, invisible fight going on, a fight against weight. And winning this fight, it's not just about saving fuel. We're talking about unlocking insane performance and building a cleaner future. This is the race to zero mass, and today, we're going to see who's pulling ahead.
So let's start with the big question. Why is mass such a huge deal? I mean, why are engineers totally obsessed with shaving off every last gram from a design? The answer is, well, it's a super simple law of physics, but the fallout from it is massive for literally everything that moves.
And there it is. That's the whole game, right there. It's just basic physics. Every single kilogram you add, whether it's part of the engine, the frame, or even you as a passenger, takes energy to get going and to keep going. So less mass just means you need less energy. Simple as that.
This is what engineers have a name for. They call it the weight penalty. It's the price we pay for every bit of unnecessary stuff we're hauling around, and trust me, it affects way more than you'd think.
So, to fight back against this penalty, the whole industry has a strategy. It's called lightweighting. And the idea is pretty much exactly what it sounds like. You design and build things to be as light as humanly possible, but, and this is the key, without ever giving up an inch on safety or strength.
Okay, so what do you actually get from making things lighter? Well, it's like a domino effect of awesome. Yeah, you get better gas mileage or more range in your EV, that's the obvious one, but it goes way deeper. A lighter car, it launches faster, it stops on a dime, it feels sharper in the corners, you can tow more, you can haul more, and get this, it even cuts down on nasty particle emissions from your tires and brakes. Seriously, every single gram you shave off just keeps paying you back.
So, the big question is, how do you actually do it? Well, it's kind of like a two-pronged attack. It's not just about swapping in lighter materials, it's about completely rethinking the design from the ground up. Right, you can't just take a steel part, make the same thing out of aluminum, and call it a day. That's not how it works. Real lightweighting is a whole philosophy. It's about looking at the entire vehicle as one big system and constantly asking, how can we make this whole thing smarter, more efficient, and just better?
And this idea of smart design, it goes way beyond just cars. Take a massive ship, for example. The friction, the drag from the water can be responsible for over 70% of its total resistance. So what did engineers do? They came up with this brilliant idea called air lubrication. They pump a carpet of tiny bubbles under the hull, and that literally helps the ship slide through the water. They didn't change the ship's material, they changed how it interacts with the world around it. Now that is total design optimization.
But let's be real, the materials themselves are still a massive piece of this puzzle, and right now we are smack in the middle of a materials science revolution.
Just look at this. This is a comparison for just one single part, a car's floor pan. Made out of good old steel, it weighs 64 kilos. Okay, now switch to aluminum, and boom, you cut that weight in half, down to 32 kilos. Pretty good, right? But now look at carbon fiber. It comes in at just 19 kilograms. That's a mind-blowing 70% weight reduction for the exact same part. So, how on earth is a 70% drop even possible? Well, a huge part of carbon fiber's secret sauce is that you can tailor its strength. See, steel is strong pretty much equally in all directions, but with carbon fiber, you can literally design it so that its strongest fibers are perfectly lined up with the forces that part is going to face. It's strength on demand. There's a cool engineering term for this property. It's called anisotropy. The easiest way to think about it is like the grain in a piece of wood, right? It's super strong along the grain, but you can split it pretty easily if you go against the grain. Carbon fiber works the same way, except engineers can control the direction of that grain with insane precision. They put the strength exactly where it's needed and get rid of the weight everywhere else.
So, we've got these incredible, super light materials. It's a no-brainer, right? Problem solved? Well, here's where the story takes a little twist.
And this is it. This is the catch, the hidden cost. It turns out that making these advanced materials, especially aluminum and carbon fiber, takes a ton of energy. The environmental price tag to produce them can be way, way higher than it is for just making plain old steel.
So to get the real picture, you have to look at the vehicle's entire life, from cradle to grave, as they say. This means you have to add up the environmental cost of every single step. You've got mining the raw materials, then manufacturing the parts, then all the years it spends on the road, all the way to what happens when it's finally junked. It's called a life cycle assessment. This chart shows that trade-off perfectly. Look at the aluminum car.
Its impact from just being built is way higher than the steel car. But because it's lighter, its impact during the use phase, when you're actually driving it, is lower. So what we're doing is we're paying a bigger environmental price up front, hoping to get savings back down the road.
Which, of course, leads us to the million-dollar question. When do those savings finally pay back that big upfront cost?
Yeah, when does using that fancy, expensive, lightweight material actually make sense from a total impact perspective? The answer boils down to one very specific, very important number.
And that number is called the break-even point. It's the exact distance a vehicle has to drive before its total life cycle impact finally drops below its heavier, old-school version. So what's the magic number? Well, in one study looking at an electric vehicle with an aluminum front end, the break-even point turned out to be, wait for it, 456,765 kilometers. I mean, wow, that is a huge distance. It tells you that, yeah, the benefits are totally real, but they are definitely not free, and you have to drive a very long time to cash in on them.
Okay, so what does all this mean for the future? Well, the push for lightweighting is definitely not slowing down. In fact, it's speeding up. But the key is getting smarter about both our materials and our designs.
The future isn't just about finding a magical new material. It's about designing more intelligent structures. I mean, look at wild concepts like the blended wing-body aircraft. Here, you've thrown out the whole tube and wings design we've used for a century. The entire body of the plane is shaped to generate lift, which makes it incredibly efficient. It's the ultimate example of a holistic, lightweight design philosophy.
And that really brings us to the final thought here. As we all start switching over to electric vehicles, range anxiety is the big monster in the room. But a lighter EV can use a smaller, a cheaper, and a much less resource-hungry battery to go the same distance. So as our entire world goes electric, this race to zero mass, it might just become the single most important engineering race of our time.